To look at your data from a Thermo LC-MS, you're going to want to use a software called Qual Browser, as in qualitative browser. You can see the icon for that software is over here on this desktop. It should be on most of the PCs in the lab. If you own a PC, you can actually put this software on your PC. And we have some kind of loaner laptops in the lab that have this software on there, so you can look at this sort of offline. But you can also see that we can set your computer up so that the Windows automatically recognizes that this file type is a Thermo raw file that should be opened with Qual Browser. Note that if you have a Mac, you can't run this software on a Mac unless you get a special piece of software called Parallels that allows you to run PC software or Windows software on your Mac. You can tell that this computer is set up to open the Thermo files automatically because of the icon next to that raw data file, that qc-heroin-2.raw. You can see there that's all set up to automatically open that in the Thermo Qual Browser software. So when I double click on this, it's going to go ahead and open up that file for me. When you open up the software, usually by default, the chromatogram is going to be on the top, the mass spectrum is going to be on the bottom. Wherever you click up top, the mass spectrum for that point in time is going to show on the bottom. And you can see here I've clicked on what looks like a tiny peak at around 0.5 up top, and that is the mass spectrum for that peak on the bottom. So you can click all around up top at all these points in time, and you'll see the mass spectrum for that on the bottom. Now, the most obvious place to click is up top at 4.12, so that you see the mass spectrum for that main peak. An important feature of this software that can really throw students off are these goofy kind of thumbtacks that I'll highlight in the top corners for the chromatogram and the mass spectrum here. Notice that right now the thumbtack is on the bottom on the mass spectrum, and what that means is when you click around on the chromatogram, the mass spectrum for any point in time will show up on the bottom. We can actually change this and click on the thumbtack for the chromatogram, meaning that we're highlighting the chromatogram. And when you do that, the reason you would want to do that is that lets you zoom in and out on the chromatogram view. But if you're clicking around and the software is not doing what you would expect, usually the first thing you want to check is, do you have the right thing thumbtacked? Unless you are zooming in and out in the chromatogram, you generally want the mass spectrum thumbtack clicked down so it is showing up in green. I zoomed in on that main peak. Now I'm going to click the thumbtack on the bottom and click in the middle of that main peak to give me a nice mass spectrum for that main peak. And what we see in this mass spectrum is one major peak at 370 with an isotope peak at 371. Now note that this Orbitrap mass spectrometer has tremendous mass accuracy. So it's actually not a correct number of significant figures to only show the first two decimal places. You want to show at least 4 or up to 5. I think the software allows 5 here. So we need to go in and change that so that we can see all of those decimal places, because those are real. The instrument is accurate out to that many decimal places. So I'm going to right alt click here and go to display options. Under display options on labels, I'm going to change this decimals to 5. And now you can see I have the full 5 decimal places on the peak. And that is the accurate mass for that. With the thumbtack down there, I can zoom in. That is the accurate mass for that peak. Now that's so accurate that I can actually use that mass to predict the chemical formula with a pretty high degree of accuracy. So if I right click on that and say generate formula from that mass, it's going to spit out a list of masses. And in this list of masses, it's giving you a list of possible chemical formula that could be calculated from that exact mass. And that delta mm is the difference in mass units, millimass units from the expected value. In this case, my calibration wasn't spot on. So in fact, the third hit here is the correct chemical formula for heroin. Now, if you look up the chemical formula for heroin, you'll see that it's C21H23NO5. And now when you look at this, it's C21H24NO5. That's because it has to be an ion to be seen by the mass spectrometer. And so this is the protonated mass. This is the protonated mass of the heroin. So it's actually C21H24NO5 plus. So while mass accuracy is quite powerful and is going to generally get us our chemical formula, if we truly want category A data, we need to get MSMS data. So I've opened up this file that has what's called a data dependent scan, and this has MS data, mass spectra, or MS1 data, and MS-MS data within that data. One tool that's going to be really helpful here to help us figure out what we're looking at is this header that I've zoomed in on, this header on kind of the top left of the mass spectrum. It's got the file name QC-heroin1 DDMS2, the scan number through 3180, which should correspond with the retention time 5.09. That AV1 indicates we're only looking at one mass spectrum and not averaging more than one together. That NL is a pretty important number. That's the actual signal level. Notice that the mass spectra are always normalized to 100%, which is pretty boring. It's hard to tell what's going on. That 1.3 e to the 8th means the signal is 1.3 times 10 to the 8th counts. Okay. Now the T on the bottom is really helpful. T colon FTMS indicates that this data was acquired on a Fourier transform mass spectrometer or an Orbitrap. The plus indicates that we are in positive mode. The P is the type of data, the profile data. ESI indicates that this was taken with an electrospray ionization source. And then after that we see full MS, 120 to 500. That's indicating that the spectrum we are looking at right now is an MS1 or a full mass spectrum. It's not a fragmentation spectrum, it's just the spectrum of the intact protonated molecule. So if you pay attention to this header, particularly that last part, that full MS versus, it'll change, you see, when we do MS-MS with fragmentation or MS2, then that'll help you kind of figure out what's going on here and what you're looking at. So now as I click around on this mass spectrum, we can see whether we're looking at MS1 spectra or fragmentation MS-MS. I'm going to find a fragmentation spectrum on this peak, and you can see now we are in fact looking at MS2 data. That MS-MS or MS2 spectrum is kind of on the edge of the peak. I'm going to look for one that's closer. This is a full MS spectrum. I scoot over. There we go. This is an MS-MS spectrum, and you can see because now it says full MS2. So most of that header is the same, but now it says full MS2, indicating it's an MS-MS spectrum. It says 370.1641. That is the peak that was isolated to generate the MS-MS spectrum. So that's the ion that was allowed to pass through and fragmented to generate fragment spectra, and at HCD 30 indicates that that is the fragmentation energy that was used. So we'll go ahead and zoom in on the fragments in this spectrum, and you can see I probably didn't use enough energy for this. 370 is still the dominant peak in this mass spectrum, what we call the parent mass. And I do have plenty of fragments to look at here, but we really want to get more fragment than parent. But these fragments are what are indicative of. That's what gives us the category A data for this technique. So this is analogous to EI data. It's not as rigorous as GCMS EI data, but that fragmentation pattern on the same instrument with the same energy, same conditions should be reproducible category A data.